Hi guys, welcome to week 3 of remote learning. The date is Wednesday, April 14th, 2020. Just like the previous 2 weeks, what you'll need is a pen or pencil, your chemistry notes, and a calculator. Okay, this week we're continuing on with our Unit 7, Stoichiometry. Now the focus is going to be on limiting and excess reactants. So in chemical reactions, usually one of our reactants gets used up first. And when that happens, the reaction stops because we're missing or we've used up one of those reactants. The reaction can't continue if we've used up one of the reactants. So that reactant is considered limiting. It limits how much of the reaction takes place, okay? And then the reactants that are left over are called the excess reactants, okay? Or the extra reactants that are left over at the end of a reaction, all right? So just like last week, I'm going to be using food for an analogy, right? I know sorry if I make you guys hungry, but food just happens to work out pretty well for these examples. So in this video, I'm going to be using the analogy of making a grilled cheese sandwich, okay? Hope you guys like my grilled cheese sandwich. I tried, this isn't Photoshop, so for now this is going to function as our grilled cheese sandwich. Okay, so when we make a grilled cheese sandwich, we need bread, cheese, and then we combine the bread with the cheese to make our sandwich, right? Of course, we grill all this stuff, and then we're ready to go. So we're going to be going ahead and using this setup down here, right? This is our recipe, so-called recipe, or our chemical reaction, right? So we need 2 slices of bread for every 1 slice of cheese to make 1 sandwich. Okay, so BD is going to stand for bread, CH for cheese, BD2CH for sandwich. Okay, so just keep that in mind. Okay, so for this analogy, let's suppose that we have 10 slices of bread and 7 slices of cheese. Okay, so I'm going to go ahead and write that out for you guys. So remember that this is the recipe, right, or the chemical equation. Now we have 10 slices of bread, okay, and 7 slices of cheese, okay? Now we want to determine how many sandwiches we can make based on the amount of bread we have and the amount of cheese we have. So just as a little reminder, last week when we wanted to bake that cake, remember we had flour, we had eggs, we had milk, and then we made that cake, right? The recipe we did last week, or the chemical equation used to make a cake, it called for 3 eggs. But in our refrigerator, we only had 1 egg, right? So we had to figure out how much flour did we need to use and how much milk did we need to use with that 1 egg, so that we made a cake, right? So that we didn't use too much flour or too much milk with that 1 egg. Okay, so in this case, what we're dealing with here is we have 10 slices of bread and 7 slices of cheese. Okay, all we're interested now in is how many sandwiches can I make given these 2 ingredients. Okay, so let's go ahead and write this out. So let's go ahead and start with our bread here. Okay, so what we're given in this reaction is 10 slices of bread. Okay, so I'm going to write 10 BD for bread. Okay, and then I'm going to go ahead and put that over 1. Okay, so we have to use the chemical equation or the recipe, to fill in this area. You know what? Let me go ahead and switch from my lightsaber to my little pointer here, okay? So this is where we use our ratio, right? Based on the chemical equation or the recipe, okay? Now we have 10 slices of bread here, which means what do we put here? We need to go ahead and put our 2 slices of bread here, right, to cancel that out. So we know that bread is going to go in the denominator, so that bread can cancel. And our sandwich, BD2CH, is going to go in the numerator on top. And again, we're putting sandwich up here because we want to know how many sandwiches we can make using our 10 slices of bread. Okay, so let's go ahead and fill these numbers in then. So according to the chemical equation, for every 2 slices of bread we have, we make 1 sandwich. So we're going to go ahead and put that here, okay? For every 2 slices of bread we have, we can make 1 sandwich. Now, bread cancels, leaving us just with sandwich, okay? Remember that we multiply across, right? So we have 10 times 1 and 1 times 2. 10 times 1 is 10 sandwiches over 2. And then we end up with 5 sandwiches. 10 divided by 2 is 5. Okay, so this number right here tells us basically how many total sandwiches we can make based on the 10 slices of bread we're given. Okay, so theoretically, we can make up to 5 sandwiches. Okay, so now we're going to do the same thing with our cheese. Okay, how many sandwiches theoretically can I make with the 7 slices of cheese? Okay, so we have, 7 slices of cheese over 1, right? And then we're canceling cheese in this instance. And in the chemical equation above, we only have 1 slice of cheese for every 1 sandwich that we make. Okay, and that gives us 7 divided by 1, which ultimately gives us 7 sandwiches. Okay, so now this is where we discuss the differences here, okay? So when I have 10 slices of bread, I can make 5 sandwiches in theory. When I have 7 slices of cheese, in theory, I can make 7 sandwiches, okay? Now, here's the thing, okay? We can only make one of these two, okay? We can't make 5 sandwiches and then make 2 more sandwiches, okay? And here's why. We only have 10 slices of bread, okay? Now, this means we can make up to 5 sandwiches. Once we make 5 sandwiches, guys, guess what? We've used up all of our bread. So that means we can't make 7 sandwiches, right? With 7 slices of cheese, like I said, theoretically, we could make 7 sandwiches, but we don't have enough bread. We need twice the amount of bread as we have cheese to make a sandwich. If we have 7 slices of cheese, well, then we need 14 slices of bread, and we don't have that. So basically what this means then is that we can only make up to 5 sandwiches, okay? We can only make up to 5 sandwiches due to the number of bread that we have, okay? So the amount of bread limits the number of sandwiches that we can make, okay? And as a result of that, okay, when we use 10 slices of bread, we end up using 5 slices of cheese, okay? That means that 2 slices of cheese were left over, okay? We have them in excess, okay, or they're extra. So what this means is that bread is our limiting reagent, okay? Bread limits the amount of sandwiches we can make. Cheese, because we have 2 slices left over, okay, cheese is actually our excess reagent. Okay, so our limiting reagent is basically the reactant that is completely consumed or used before others. It determines or limits the amount of product formed. Okay, so the limiting reactant is the reactant, okay, for instance, in our example, it was bread, okay, the reactant that is completely consumed before others. So our bread was consumed before all of the cheese was consumed. It determines or limits the amount of product formed. So our bread limited the amount of sandwiches we could make. Okay, so now for the excess reactant, this should be fairly straightforward, right, guys? So for the excess reactant, it's simply the reactant left over after a reaction has completed. So as I said, we were left with 2 slices of cheese, right? So those 2 slices of cheese is evidence of excess reactant, right? So like I said, the cheese is our excess reactant, the bread is our limiting reactant. So let's go ahead and move on to a couple examples here. Okay, so now just before I jump into these 2 examples, I just want to highlight that there are 2 ways to determine the limiting reactant. Okay, so I have 2 examples to show you. I'm going to go ahead and show you those 2 ways in the first example, and then in the second example, I'm going to show you the primary way that we go ahead and find the limiting reactant. Okay, so here's our first example problem, and just as a reminder, I'm going to go ahead and show you guys the 2 ways that we can solve this problem here, okay? So the problem says to calculate the amount of CO2 that can be formed from the combustion of 3 moles of propane and 12 moles of oxygen, okay? So this is a combustion reaction. As always, we form the compounds CO2 and water, okay? So what we're given here is 3 moles of propane and 12 moles of oxygen, okay? And we want to know what's the maximum amount of carbon dioxide can we form using these 2 values here. Okay, so the first way that we can determine the maximum amount of carbon dioxide goes like so. Okay, so I'm just going to put first way to determine. Okay, so what we're going to do is we're going to go ahead and divide the given moles by their respective coefficient. Okay, so in other words, okay, the given moles here are what the problem gives us, okay? 3 moles and 12 moles, okay? So we're going to divide the given moles by their respective coefficient. So in this case, in the reaction equation, okay, propane has a coefficient of 1. Oxygen has a coefficient of 5. So we're going to divide what we're given by those coefficients, all right? So let's go ahead and set that up then. So for propane, here's what we have. We have 3 moles divided by 1 mole. Remember, there's a little 1 here. We just don't write it because it's a bit redundant to write 1 divided by 1 mole. Okay, now 3 divided by 1, obviously that's 3. Okay, so now let's do the same thing for oxygen here. Okay, so we are given 12 moles. Okay, we have 12 moles. And in the reaction equation, we have a coefficient of 5. So we're going to divide our 12 moles by 5 moles, and what that gives us is 2.4. Okay, so here's the catch. This is the way it works. The limiting reagent, okay, is always the compound with the lowest value. Okay, again, the limiting reagent is always the compound with the lowest value. Okay, so if we compare 3 to 2.4, obviously 2.4 is our lower value. Okay, that means oxygen, okay, our 12 moles of oxygen is going to be our limiting reagent. Okay, so for this, just based on this quick calculation, oxygen is the limiting reagent. And if oxygen is our limiting reagent, that means propane is going to be our excess reagent. Okay, so we're gonna use up all of our oxygen. Okay, and we're gonna have a little bit of propane at the end. So the maximum amount of carbon dioxide that can be formed depends on when oxygen is used up. All right, so this is the first way to determine the limiting reagent. I'm going to go ahead and show you the second way to determine the limiting reagent using the same problem. It is a little bit more extensive, but it'll get you the same answer. Okay, so here we go. Again, remember this is the same problem. We are given 3 moles of propane and 12 moles of oxygen. Okay, so this is just setting it up using the coefficients in the chemical reaction, okay, or using the coefficients in our recipe. All right, so we're going to go ahead and we'll start off with, we'll go ahead and do propane again, okay? So in the reaction, what we're given is 3 moles of propane. All right, stick that over 1. Okay, now in our formula here, okay, we have 1 propane molecule, or 1 mole of propane to 3 moles of carbon dioxide. So we're going to go ahead and put propane on the bottom and CO2 on top. And then we're going to go ahead and write in our coefficients. We have 3 from carbon dioxide and 1 from propane. As you know, propane cancels, leaving us with CO2. And what we end up with here is 3 times 3 divided by 1, which gives us 9. Okay, so we have 9 moles of CO2, okay, from using our propane. Okay, so now we're going to go ahead and do the same thing with our oxygen, all right? So we're given 12 moles of oxygen. All right, and according to the formula, for every 5 moles of oxygen, we have 3 moles of CO2 that are produced, okay? So we write this out. Again, moles of moles of oxygen cancels, leaving us again with CO2. 12 times 3 is 36, divided by 5. That is going to give us a value of 7.2 moles of CO2, okay? So let's go ahead and analyze this, okay? Now, what we ended up with is a smaller amount of CO2 when we used up all of our oxygen, Okay, so when we use up all 12 moles of oxygen, we're only going to end up with 7.2 moles of CO2. Once we reach this value here, we've used up all of our oxygen. We don't have any more oxygen, which means we cannot go beyond this value of carbon dioxide. Okay, propane here, with the amount of propane that we have, 3 moles, in theory, we could make up to 9 moles of CO2. But we don't have enough oxygen to do that, okay? So as a result, oxygen is going to be our limiting reagent, okay? And the most we can make of CO2 is 7.2 moles. All right, guys, here is our last example, okay? So in this synthesis reaction below, okay, determine the maximum amount of water that can be produced between 150 grams of hydrogen and 1,500 grams of oxygen, okay? So remember, anytime we're asked for the maximum amount of product that can be formed between the reactants, we're working with a limiting reactant problem, okay? We want to know which of these reactants is going to limit how far the reaction can go, and which of those reactants is going to be left over in excess, okay? So this problem is really no different from the last problem. The only difference here is we're given grams of each reactant, okay? So for our hydrogen, we are given 150 grams of hydrogen. For oxygen, we are given 1,500 grams. It's a lot of oxygen. Okay, so we want to know how much water can be produced. Okay, so again, like I said, this is exactly like the other problem. There's just one additional step. Okay, we have to go ahead and convert our grams into moles. All right, so let's go ahead and do that. So we have 150 grams of hydrogen. We're going to pop this guy over 1. Okay, and for the molar mass of hydrogen, I'm going to go ahead and put 2.02 grams. Okay, 2 grams per mole. Okay, and remember, we multiply across and then we divide. So 150 times 1, that gives us 150. We have to remember to cancel our units. Grams cancels, leaving us with moles. So we have 150 moles divided by 1 times 2.02, that's 2.02. And what that gives us is about 74 moles of hydrogen. Okay, now we're going to go ahead and do the same thing with our oxygen. We have 1,500 grams of oxygen. Okay, so in 1 mole of oxygen, I put 32 grams of oxygen. Same thing here, guys. Grams cancels, leaving us with moles. We end up with 1,500 moles divided by 32. And what that gives us is 47 moles of O2. Okay, so now we've determined, okay, how many moles we have. Okay, so I'm going to go ahead and remove these guys and replace them with our moles. Okay, so we have 74 moles of hydrogen and 47 moles of oxygen. Okay, let me go ahead and just quickly erase this for you guys. All right, so now we're just basically doing the same thing we did in the last problem, okay? If you want to solve it the first way I showed you, go right ahead, where you divide what we're given by the coefficients, or you can do it the second way. I'm going to go ahead and do it the second way, okay? So what we have, we'll start off with hydrogen. We have 74 moles of hydrogen, okay? Now, in the reaction equation, we have 2 moles of hydrogen for every 2 moles of water, Okay, so we're going to put water on top, hydrogen on the bottom, and it's 2 to 2. Right? Hydrogen cancels, leaving us with water. And we end up with 74 times 2 divided by 2. That's going to give us 74 moles of water. Okay, so now we're going to go ahead and do the same thing with oxygen. Okay, so we have 47 moles of oxygen. And for every 1 mole of oxygen, we have 2 moles of water, right? Moles of oxygen cancels, leaving us with moles of water. And we multiply across, and we get 47 times 2, which gives us 94 moles of oxygen. Okay. So, obviously, we know that this is the most amount of water we can form, okay? Which means that hydrogen is the limiting reactant, right? And then basically what that means is that oxygen, okay, oxygen is going to be the excess reactant, okay? So when we use up 47 moles of oxygen, okay, in order to use up this many moles of oxygen, we need twice the amount of hydrogen, okay? Because in this reaction equation, for every 1 mole of oxygen, I have 2 moles of hydrogen. If I have 47 moles of oxygen, I would need 94 moles of hydrogen. And I don't have that. I only have 74 moles of hydrogen. So as soon as my 74 moles of hydrogen is used up, that's all I can make. That's the most amount of water we can make. And because of that, because this reaction is dependent on our hydrogen, hydrogen limits the amount of water we can make. And so therefore, hydrogen is our limiting reactant. Whereas oxygen, we have plenty of oxygen left over. Okay, so we did this reaction in the classroom, actually. This is when we had the balloon, and there was a volunteer from the class, and we attached a candle to the end of a meter stick, and that person, that volunteer, whoever it was, went up to the balloon while the candle was lit and put the flame up to the balloon, and it exploded. And it was a fairly large explosion, right? That was the reaction between hydrogen and oxygen, and we formed water. Now, guys, in that room, we did it in our classroom, right? And our classroom is full of oxygen. That balloon had a fair amount of hydrogen in it, but nowhere near the amount of oxygen in the room. So this is actually a perfect explanation for that reaction, okay? We had plenty of oxygen left over after that reaction took place, okay? So hydrogen in a reaction like this generally is the limiting reactant, okay? Oxygen, there's plenty of oxygen to go around. It's usually the excess reactant. All right, guys, so that does it for this video. Next week, I'm going to go ahead and be going over how to determine how much excess reactant is left over. And then we might get into percent yield and other things related to stoichiometry. All right? Make sure that you guys copy down the notes from this video and upload them by Friday at 5 p.m. And that's it.